Thank you. Good evening, everybody. I'm going to share with you on the latest development of the retractable noise barrier. This is an invention. It is jointly developed by Wilson Acoustic and Acoustic Innovation. Why we have acoustic innovation? Because during the R&D process, we found that the job nature of the R&D is very different from the consultant service. So we found that in order to make an efficient development, we need to set up another company in order to develop such a product. Okay, let us start. This is not asking you to silent up. This is the name of the noise barrier. Because this noise barrier is silently upward, we can install the noise barrier very silently. So we call it silent up, like this. So silent up is actually, if you type retractable noise barrier in Google or Yahoo or any search engine, that is the only one appear in the entire internet. So I could not find any other country have such a retractable noise barrier. So you can see a few YouTube, and this is from our company showing how the retractable noise barrier. Okay, a normal conventional noise barrier is 3 to 6 meter height, subject to the foundation conditions. A concrete foundation and steel structure is normally required because for the wind loading of 1.2 kilopascal, that is quite high. That is actually is around 150 kph. So normally the noise barrier need to design for a wind loading of 150 kph because it is ensure it will not fall down. So such that large machine required for the installation. And the other type of noise barrier called movable noise barrier is some kind of misconcept. Movable, you cannot move without a machine. It is, although it's slightly lower, it's 2 to 4 meter height, and it still need a heavy base, but it is still as heavy as half ton. You need a crane to move it. So whether this barrier is enough for various site conditions in Hong Kong, let's see a few examples. This is one of the examples. The water supply department during a water pipe replacement. On one side there is this is the pedestrian walkway. On the other side is a operation road. There is no space for putting the conventional noise barrier or even movable noise barrier. Is no space to put the movable noise barrier. And also, you cannot imagine how a crane can be accessed this location. If they need to put a crane, probably they need to put in this side, and then the entire road will be brought up. So then they need some kind of new type of noise barrier in order to screen the construction work. Another example, if some construction work underneath a podium, then this should be good enough, but there is an opening. The opening is also a car access road. Although this road is only used a few times a month for the material delivery, but if a conventional noise barrier built there, it do not allow because the car need to go in and out. So they need to build a door. The third type example I call is Sunday barrier. Sunday is happy day, but for construction work, some of construction work they need to carry out continuous 7 days. On Sunday they need a specific barrier because some activity they need a barrier. For example, in this case is the rubble handling. Handling of rubble is considered as the prescribed construction work, so they need a barrier to screen it. So if they build a barrier to surround this activity, it will block up the site access road and slow down the site activity. So they do not allow to build a barrier on daytime or on the weekday. Okay, it is clear that there is many other examples. We need a new type of barrier. What is it? It could be quick and fast installation, don't need to do any foundation work, structure will not fail during the occasional gust. And then good sign insulation, because the barrier, normally the barrier panel is very good sign insulation. The problem is the interface gap. How to seal up the gap is very important when you're making a barrier. And then easy transportable. So whether we can make it, we make it. So we call it retractable noise barrier. And this is the first one in the world. Okay, let us quantify the requirement. It should be at least 3 to 6 meter high, same as the conventional noise barrier. The insertion loss should be more than 15 dBA for the prescribed construction work requirement. Also, it should be very quiet such that it can be built after 7 p.m. because after 7 p.m. there is a noise control ordinance and require all the PME, the machine is not allowed to use. So then we make our design. As we have this idea for a few years. So when we make the design, we make much better than this requirement. We try to make 8 meter high noise barrier, and the panel installation is more than 18 dBA reduction. And we are very quiet process such that only the major noise is speaking. So if the worker do not speak, then it would be very quiet. We don't need a machine. The interface gap we are designed with automatic sealing, so ensure all the panel would be automatic seal up to a good position. And also the all components are decided to be less than 10 kilogram, except the water barrier base, it is about 15 kilogram. And then the panel surface density, we want to minimize it. At the moment, we are at 5 kg per meter square and 3 kg per meter square. We are still want to minimize the panel's weight, but do not satisfy the noise insulation. Also, the lightweight, safety concern, low cost, user-friendly, durability, all this need to be concerned. Okay, when we consider the entire design, we find that the wind loading is the most critical factor. We must solve the wind loading process. Okay, let us see some video. I hope this video well. Is it? How can I? Okay, this is the first prototype. We try to verify whether the automatic sealing is working. So you can see when the panel going up, the upper side of the panel can be automatically sealed up to the pole, and the other panel can be automatically sealed up to the adjacent panel. You can see we are using a metal film at the bottom. This metal film is the grid ups quite a lot of problem because this metal frame, we need a lot of counterweight. The counterweight for this barrier, if we need to make reasonable stability, we need 300 kilogram of counterweight in order to make this barrier to a reasonable stable. So it makes a lot of problem if we're using a metal frame foundation, metal frame based structure. Then we have another one. Okay, there is another one. We solve this problem because the frame structure give us a lot of problem. So we solve it by using water barrier as the structure, as the base structure. So there would be another frame. All this you can find it from YouTube. So you just type retractable noise barrier, then you find all our installation. So this is some kind of technical every time we encounter. So it's like some kind of R&D work. Is it working? Is go to the okay. Click on it. Okay, this is another one. We are now using water barrier. The installation time is actually less than 10 minutes. When the next day we do it again. This is the acoustic mat, and then they put a 5 meter, 6 meter high carbon fiber tube. Push up the panel from ground level, so we don't need a machine to make a high barrier. Then there is an automatic shield at the top. This is actually a demonstration witnessed by our client Leighton, the NTR, and the authority EPD. So we did an insertion loss test. The result is better than 23 dBA. So with this noise barrier, the noise level reduced. We have a few measurement locations. One measurement location has 26 dB reduction, and the second one is 23 dB. So we take 23 dB as okay. And so at the moment, SilentUP barrier is up to 7 meter. Although we decide to 8 meter, it will become very soon 8 meter height. Installation by people only without using machine, low foundation requirement. The average construction time for one column is around 10 minutes. A panel is sliding upward from ground level. A U-channel design for the panel edge interface. Each column connect to the next column by mallet, so it's automatic shielding. And the process is when the panel is at a right position, the magnet will attract it to the right position. Once at the right position, the U-channel provides the lateral locking force. So it locks the panel, so it becomes very strong. You cannot push it open. You need to, if you want to push open, you need to give very, very strong. Is stronger than you push open a heavy door. You need around 20 kilograms to push it open. So once it locked, it will be really locked. And this U-channel is also providing for the upper panel, lower panel interfacing. So at this and also at this, carbon fiber tube is using as the major structure. We make our carbon fiber tube in China. So specific make such carbon fiber tube. Nobody make it. They do not. They think this is silly idea. No people in the world make it this carbon fiber tube. But I asked them to make it, then they specific design for us. During the occasional gust, if it is higher than 35 kph, the panel would be open like this. So this opening is in order to prevent the entire structure falling down. So the structure design is, instead of the normal conventional noise barrier talking about 1.2 kPa, we only need 0.1 kPa. So this is why we can using lightweight structure to build the barrier instead of the steel structure. In addition to that, we want to ensure it will open. The panel will open before it falling down. We have a differential pole mechanism. That means when the pole have a little bit movement, the panel must open. let me explain in detail. It opens like this. So you can see that there is water barrier, the poles, and then there is a supporting neck. The supporting neck is an alternative location. One is on this side, the other on that side, the other on this side, and the other on that side. So this is alternative position of the neck. Okay, this is the pen wheel. Then let you understand. The noise barrier is there. So let's go back to see the. You can see this is the neck and the pole, the water barrier, and the panel is in between two poles. So go back to see, compare the location. You may get more understanding. Okay, this is the barrier location. Then when the wind blow on it, what happened? All the pole will move, but some structure pole will move more, some structure pole will move less. This pole move less, this pole move less. Then the distance between two poles is increased. Although the increase in distance is only 10 millimeter, but this 10 millimeter is make the difference. The 10 millimeter is enough to pull the panel outside the U channel. Once it's outside the U channel, it will automatically open. So this is the design to ensure if there is the structure is starting falling down or not falling down, the structure is a little bit movement, it will allow the panel to open. Okay, the problem. And then on the other side, talking about the magnet. The magnet have a very strong magnet, very small. If the magnet like this, it is stronger enough to hold the entire body. So in the nowadays, magnet is very strong. If we have this magnet, be careful. Your finger will be 夾扁，好容易夾扁嘅。So our worker, many of them 好容易俾個 magnet 整。So when the magnet they come to contact each other, they will give a very high force. But if they are few millimeter apart, so in this example is about 7 to 8 millimeter in separation, the force will be reduced to 1/3. Then the magnetic force is not strong enough to hold the panel. Okay, then we ask, is it open every hour or every minute? Once the wind blow on it, it will open. So we decide for 35 kph. If the wind could not achieve 35 kph, it would not open. How often the wind achieve 35? We set up a wind meter at our rooftop at the 6th floor of Satin, and then measure the wind speed. And during this November to February, there is every day, most of the day is gust speed, maximum gust speed is 10, 15, sometimes 20, 25, 30, but only one day they have 41 gust speed. So according to this data, it only open once a few months. When it open, it's not a quick deal. Somebody going back to close the panel. So if 41 kph, actually most of the barrier, I mean those barrier with flexible mat will already damage. We compare this data to the Hong Kong authority data. They have similar value, but we are not sure whether the monitoring position. We want to get the urban area with gust speed. Okay, on the this showing the actually there is only less than 0.1% of time with gust speed is higher than 30 kph. So it open. I think it may open once a month. If that is a windy section, it may be a few times a month. So, but that normally not a big problem for the construction site. We have 3 types of panels. Panel type A, because the performance is best, so we call it type A. It is a multi-layer design with flexible mat, aluminum plate, and then polyester fiberboard. Currently, we can make it 7 meter height. The density is 4.4 kilogram per meter square, and then we have 23 dBA insertion loss measurement result. And then we have a Type B panel. Type B panel is the future. We will spend time on to improve it. It is a 2-layer of flexible mat separation by 100 millimeter. Because this separation, we can make a lightweight panel and still achieve a very high insertion loss. Okay, it is reduce the panel surface weight to 2.6. This is very important because a large barrier, if you count it, then you find this we have to reduce it. Otherwise, it is not handled by man. Then the third type is air tip, plastic air tip. Is very lightweight, but the performance is not good. It's only give 11 dB reduction. Actually, it would be better, but because for this project we do not have sufficient time to test it, and we got 11 dB approved by the authority. Okay, let's see the panel. This is the Type A panel. You can see flexible mat, aluminum plate inside it, and then polyester board. And it can handle by 1 people, and each panel is around 7 kilogram. So if 4 together is 20 something, 5 together is more than 30. So when we need to push up this panel, it's quite difficult. Type B is 2 flexible mat, separation and 100 millimeter. This type of design we think have highest potential for further development. We can change each mat to different density. We can add material inside the between the 2 barrier. So when it open, it is different from the others. The previous one, when it open, it is at the edge, like a door opening, a 1 lid door opening. But this is look like a double lid door. It open on both sides. So the opening is at the middle of it. With this design, it is more easy to push it upward because the center of gravity of the panel is in the middle, close to the pole, so it's easier to push it up. When you see the video, you find that it is quite hard for the worker to push it up because the weight is blocked at the pole. The weight is off the pole. So, then also when it open, the clearance for opening is half of the previous one. The previous one we need 1.3 meter clearance, but this is only 0.65 meter clearance. Okay, the third type is the plastic air tip. This is just air tip. So you can see the photo later. This is the it can hold by 1 people. It only this panel, entire panel, is only 1.6 kilogram. And okay, then this is the spectrum or the insertion loss of the feed type of panel, and we got 23, 20, and 11 for this feed type of panel. And we found that there is a dip there. This is 1,600 Hertz. What happened at 1,600 Hertz? Why they have this dip? It is suspected that this is the half wavelength of the sound, because the wavelength of this sound is around 200 millimeter. 100 millimeter is half wavelength. It would set up a standing wave, and the standing wave would making the noise transmission is easier. So for this reason, I think we can have something to make this a better performance. Okay. Then for the structure, we do finite element analysis and then test on site. So the first of all is the carbon fiber pole. This is the long carbon fiber pole. And we are doing a worst case simulation, wind speed 40 kph, 7 meter height, actually it opened at 35 kph. So this is worse than actual. And the pole thickness is 2.6 millimeter. The simulation result showing this location at the bottom connection. This is the water barrier, the base frame. Then this is the connection. The connection have highlight string, and the value is 170 megapascal. For the yield strength of carbon fiber is 210 around. So it's too close. It's too close. So although it's worst case simulation, it's too close. So we increase the thickness to 3.5 millimeter. And the other element is the supporting neck. The neck there, and there is a wire to push it up, to pull it, in order to. Then when the wind blow on it, it creates a stretch there. The stretch is the string is 135 megapascal. Normally for steel, it can easily achieve 200. And this is the conservative simulation. We assume there is no friction. Once the friction on the ground, it will reduce the string by half. So this is, I think, is enough. So if not enough, we just increase the this leg to thicker steel. Okay, short reference. At the moment, we did one by one. This example, you already seen the photo. How we can make the noise barrier? Is it possible? We make 3 meter high barrier on both sides. When we look at on pan, this side is a 300 meter long side. And every few days, the construction activity will move. So if the barrier can be moved according to construction work, it will be much better. Okay, this is the barrier we make. 3 meter high. 3 meter high. Although you can see there is a hole at the water barrier, it is actually covered by acoustic mat. You can see there is an acoustic mat covering the barrier. Then it seals up all the gap. And the worker is actually working at 1 meter below ground. So it is quite effective for the noise insulation. So this is also easy to move. Every day, only 15 minutes we can install all this panel. So they can move the water barrier to the next location, then install the barrier again. Okay, apart from that, there is some roll machine, pavement machine or concreting machine. They are moving very slowly during the construction. Maybe every hour move 10 meter, something like this. So doing the roll work. So what we did another type of movable barrier. Somebody. Okay, this, if we really can't open it, then you can. Okay, that actually you can find it from the YouTube. There is a 2 meter high movable barrier. It can move by one people, just pulling the entire barrier. And our colleague is trying to find out the barrier. Okay, so 2 meter. Which one? Oh. Okay. I'm sorry that there is some problem in the. I think if we can connect to the U-tip, then you can find the 2 meter movable barrier. There is only one in the U-tip. And maybe somebody help me to find it out, then at the end of the presentation we will show it. Okay, so we just carry on. Sorry for this technical problem. So, okay, when you. But if you're using your phone 2 meter barrier, 2 meter movable barrier, you can find it in the YouTube. Okay. construction is underneath the podium or the Hongham station. Entire Hongham station, many construction work inside there 24 hours. However, they need some barrier at the north opening there and the south opening there. So we look at it one by one. There is a lot of the construction work. They have a mini batching, movable batching plant inside the podium. They need a loader to feed the batching plant at this location. And there is a noise barrier at this. This is 4.2 meter high retractable noise barrier. Another barrier, it is 5.8 meter high. And 2 meter high barrier, retractable noise barrier at this location. So this is the barrier. It's sorry, the light is not strong enough. When I asked the engineer, asked them why they don't use the conventional noise barrier, they told me that to make such a barrier, 2 width is not enough for them to design the foundation. Because when they make a barrier like this, they need to make sure it would not fall down. They need 2 widths to design and then find out the suitable material, then purchase the material. But we only need 2 hours. If you call me, I can make the barrier 7 meter high in 2 hours. So this is the difference between the conventional noise barrier and the retractable noise barrier. Okay, this 3 meter high barrier. And on the south opening, this is the photo you already seen. How can we handle it? This is looking from the outside. We are going to build a 4.6 meter high barrier with the water barrier base at the bottom. So this is, after we build, it looks like this. And actually this is the entire process is witnessed by the authority. And at this site condition, we still get 17 dBA insertion loss. So this is acceptable by the authority. And then this Sunday noise barrier, how can we build it? This is the noise barrier location is blocking the side entrance road. And this is when it make it look how it look like. It is 7 meter high on this side. This is 5.8 meter high. Looking on this side, there is, you can see the barrier is already obstruct half of the road. And there is another type of panel. This is called Type B panel. This is Type A panel. This is Type B panel. So another film, we hope this film could be okay. So you can see the 7 meter high carbon fiber can be handled by one man. So each column takes about 10 minutes to construct. Okay, this is showing how it constructs, and all the video you can find from YouTube. Patent and recognition. We have quite a lot of patent. So when you see this, it is, I mean, the money spent on patent is quite a lot, and also the time. And also, Then we also got an award from the INCE, the International Institute of Noise Control Engineer, for a paper representing this concept of retractable noise barrier. And actually, this is an adventure journey of the R&D development on this SilentUP. Why I share this with you? Because in Hong Kong, the education system tell you what is an invention. An invention, when you are in the kindergarten or primary school, the teacher told you that when the apple falling a tree and hitting the head of Newton, then there is the Newton's law is run. By this way, just an apple hit on the head. But actually, I found that this is totally different story. Maybe we are not good enough. So I share with you some. In 2012, we already have all the idea. Most of the idea is in 2012. We have the idea how to construct a lightweight structure. We have different idea to how to reduce the wind load, although it's not detailed enough, but we have all the idea. Then we finally take another few months to find out to let the panel open is the only practicable way to reduce the wind load. Then we tidy up all the idea, make a provisional patent on April of 2013, and then we establish a new company to do this R&D work, because we found that when people doing the consultants work and R&D work, normally they would the R&D work will be totally stopped because the consultants work there is deadline, whatever, and the R&D work is even you don't do, you have no progress, it's no problem because there is no client to push you. So once we establish a new company, we have dedicated engineer to work on it. Then we really start the R&D process. Then after how many months? 18 months. After 18 months, we can see the first demonstration to the client. So it is actually 18 months hard work of a field engineer in order to achieve this. What I want to share is this adventure is actually need some kind of courage because most of the trials are failed. So if we test 10 different weights, out of maybe 10 are failed. So this is how, and actually our company, many staff don't like to work on the R&D group because the failure rate is so high. So this is we test the air tip. So this is the air tip inside the Type C panel. We test multiple layer and then find, okay, if multiple layer, it will give sufficient noise insulation. Then we put up it, and in the beginning it looks good, but a few hours later it looks like this. And then we different way to put up it, trial, and we trial different layer to find out any different way to make a lightweight structure and high performance, high sound insulation performance. This is an idea we try a few months and finally we give up. This is a horizontal hinge opening. When the wind blow it will open like this, like this. And then when the wind do not blow, it will close up automatically. In principle, this is very good design, but we try many months and found the design is too complicated to make it practicable. So at the moment, we give up this idea. And this is the first one. We try the magnetic sealing method. Then we, in the last year, May, we joined the construction symposium to promote this idea. Then we try different ways to put up the roof. This is very lightweight. Just have the air tube and a flexible mat. The entire weight is less than 1 kilogram per meter square. And also we make an enclosure. So in the first job, in the WSD pipe replacement job, actually we also make an enclosure so they can make a noisy work even at night time. This is the ventilation there is a bowler, then the ventilation fan blowing air out this. And we make noise measurement at different location, different height. This is, I forgot how high it may be, 8 meter height microphone. 8 meter height is quite high for normally to do a noise measure. But at the moment we can make 20 meter high microphone. So if there is 20 meter high microphone, we don't need a crane. We're just using our technique to make this. We spent many years to develop this. And this is on site how it looked like the enclosure. We also test different type of the roof. We try to, at the moment, we cannot find a good way to make a roof. We found that even a very slow, slight wind, it would very sensitive to the wind. 6 meter high, 7 meter high. So we all this is already done, the prototype. And then 8.3 meter height. We are sure we can make it, but at the moment we are not sure this carbon fiber tip is strong enough. So we are requesting the carbon fiber tip manufacturer to make a stronger carbon fiber tip, then we can make this 8.3 meter. And we test this this panel. In the first one, it only gives us 7 dB reduction because the noise leakage of this. Then we seal up the gap by using the tap. It changed to 17. Last week we're using a specific way to seal up the gap. We have 20 dBA reduction. Okay, this is the future development. We will sure making this 8 meter high carbon fiber tip, and we already done the prototype testing. A is the detailed design, B is the prototype testing, C is the on-site installation. And then we think we will do it very soon. If we make this vertical barrier turn 90 degrees, then it become a rooftop, a roof cover. And we have the design for 15 meter wide shop. If you have a shop want to cover it at night, we can cover it. If it is not wider than 15 meter, we can cover it after 7 o'clock without using any machine, and give you around 20 dB noise reduction at the cover. So, and if I think we are able to make it up to 20, but need more time to design. And we also make a canopy top about 5 meter. And this is another idea. We have already an idea how to make a noise enclosure tunnel for the concrete lawn mixer. So we can make a tunnel of 10 meter or 20 meter long, starting from the side entrance to the concrete unloading point by this tunnel. And the entire tunnel can be constructed at night time after 7 o'clock. So then for talking about the piling rate, the piling rate is very high. It's higher than 8 meter. Because it's the small area, and there may be other support from the piling, the crane. So we have idea how to make a 15 meter high noise barrier for the piling rate, and it is possible to achieve 25 meter. We are focusing on the Type B panel. There is a lot of improvement, and we are designing another type of the base, structure base, other than water barrier. So I hope you will give me more idea how to develop this retractable noise barrier. This is the product from Hong Kong. 2 months ago, we win an award from the organized by the Hong Kong Science Park and the Hong Kong Poly U. And we got some financial support on the loss, because we lost a lot during this development. Talking about, okay, a lot of money. So then we win this award, and we are invited to get into the science park. So we are moving into the science park. The Acoustic Innovation Limited is actually the R&D division of the Wilson Acoustics is moving into the science park. In the first phase, we are 5 people moving in. And then I think later we will have about 15 people in a few months later. So we hope after moving in, we are joining what they call technical incubation program. They will tell us how to make this loss to be a profit, how to run a business, how to run an international banking. So this is what we are at the moment. So hope you enjoy it and give me some idea to improve it. Thank you very much.
Thank you, Wilson. It is time for us to answer any question to our speaker. The topic is very interesting. I haven't seen it before. I think I need to visit some of your sites so that I can have a look. If there are no question, I will ask Sherry.
I have a question on the I have a question. Can you talk to the durability of the panel? Because it's quite a rugged environment. So how easy is it to puncture, damage, tear?
You very good observation. Actually, the panel at the moment is not durable. The major problem is aluminium. Aluminium is very easy to fatigue and very easy to damage. When the worker do not handle it well, it could be easy damage. At the moment, the panel life is about half year, less than 1 year. So we need to improve the design. However, we also have a limit on the panel weight. So we are going to make this a flexible panel with the 2 layers of flexible mat. That would be much harder to damage. So I think we need to give up the aluminium, the idea of using aluminium as the structure, because aluminium would be easily damaged. I hope this.
All right, thank you.
Yes.
Hi, Wilson. You have shown that the panel opens when the wind blows one way. The wind doesn't have direction. So what happens if it blows the other way?
It is designed to open on both sides. There is no, actually there is no difference whether it open on one side or on the other side. This is the major problem when we design. If we know which way it open, then the design is much easier. But we have to decide it could be open on one way or the other direction.
Any more questions? So Wilson, you have mentioned how to install the panel within 10 minutes. How about demolition?
It's much faster. It may be 1/3 of time, less than half. Because the difficult time is to push it up and try to, although it is automatic, but you still need to make the panel to an approximate position. And then you need to try a few times until the panel to the approximate position, then the magnet will attract it to the right position. This sometimes take 1 minute. But when we demolish it, if we just push it out,
push it just like a in low.
Push it, and then when you demolish it, you push it out. It's not easy to push. There is some way to some technique to push it. First of all, we need to pull the panel out before pushing. So there is two force. One force is pull out the panel, then push it. Otherwise, if just push it, it's too hard to push. And then the panel drop down is very easy. Demolish it one by one.
I would like to know about safety regulations, right? When you finish the cell, will you need somebody, right, to certify as safe? And do you need some license or certification for safety operation?
I'm not the suitable guy to answer these questions. I think our client, the contractor, they have their own safety requirement, and we provide the design, we provide the structure calculation, we provide all the finite element analysis, and then all the safety concerns will be handled by the contractor. Actually, our contractor is very, very safe. I never see a contractor is so safe. In one process of the installation, somebody need to stand on 0.6 meter height, same height as this chair. Somebody need to stand on this, and then we need people to doing this instead of as easier, because it just which the height is a little bit difficult for some short people. So we have ladder, very low ladder, but our client do not allow us to do it. Without it, we can still do it, but it's just more difficult for short people.
It's important to provide a safe means for the workers.
Yes, I agree.
If not, then
I have prepared one question and think somebody would answer. So let me share the questions. Because in the industry there is a lot of people saying that the air tip, blowing up the air tip would make a noise enclosure. So we compare this. The next. Okay. So let me ask a question for myself. Okay, this the next. Okay, this is also is testing on our site. We test to blow up this air tip to make an enclosure and measure how much noise reduction by this type of enclosure. It looks very easy to make this, but actually there is a lot of pump inside, and the pump is very noisy. So we want to make a quiet environment to build a noise enclosure, but this is making noise. The pump itself making noise, and also the gap between the tip is also very difficult. In order to make it stable, it need to have rock to. So it need a lot of clearance space in order to make this. So I found that this idea is quite difficult to make it practicable inside. Although there is some paper talking about this in Japan, making use of this type of noise enclosure. I tried it, I found that this is not practicable or not easy to make it practicable. So this is some sort of, we make the noise measurement. Although it still can achieve 11 or 12 dBA reduction, but actually the air tip can only give high frequency attenuation. For low frequency, the attenuation is only 2 or 3 dB, almost nothing for low frequency. And okay, this I make a table to compare this two. So this is the question I prepare for myself. If nobody answers, I ask and answer. Okay, so inflatable air tube, does it can it resist wind load? Actually, it cannot resist wind load. And if there is 35 kph wind load, the entire shape will be changed. And actually, I think it's quite difficult to make it stable. But this why I'm doing this, because many people in the industry ask me whether this is possible. So instead of answering this question by doing some kind of literature survey, I'm buying this air tip to test it, and I found this is there is still a lot of things to do in order to make it practicable.
Yeah, if no more questions, then we make a normal way to thank Wilson for his sharing. Thank you. Quite interesting.